All right, so I got kind of carried away there with my imagination, but if we just focus on this part, that gives us the instructions of what to do. We are trying to find a point where the electric field is 0. So um, we're going to have two infinite plates. So let's try to draw them in. And that's at x equals 0. It's a vertical line. And at x equals to 10. It says that the coordinates are each 1 meter apart, so these plates would be 10 meters apart. And there's an electric field between them. It says that the left plate is positive, the right plate is negative, and the electric field between them is 10 to the 10. The electric field would go this way, to the right. It's going to go towards the negative plate. I'll just call that E for now, but the value is known. It's 10 to the 10. Okay, it says place a large metal sphere at the point 5, 5. So at this point here, that's going to have coordinates 5, 5. And it's going to be a metal ball that's got a 10 coulomb charge. And it says after you place that ball there, that's going to reveal where the 7th infinity ring is going to be found. It will be found at the precise location where there is an electric field of 0. So this ball, this 10 coulomb ball, I'm going to make it red. I've been using red for most positive. That's going to create its own electric field. It's going to go in all directions around it. So this electric field from this red ball, it's going to combine with the electric field created by the plates. And there's going to be some point, there's going to be one point somewhere where those two fields perfectly balance out to make 0. And that point is going to be somewhere over here to the left of the 10 coulomb ball. That's because the ball will create an electric field to the left, whereas the plates create an electric field to the right. So left is going to balance out right, and we've got to find the precise location. So what I'm going to do is I'm going to have the distance between them be called x. Or no, I don't even need to do that. I can just call it r. R, because R is what's used in the formula for the electric field of a point charge. So I'm just going to find that distance R such that the electric field created by, I'll call it the ball, will equal to the electric field created by the plates. They're going to be equal in magnitude. I already analyzed the direction. They're opposite in direction. So I just need the magnitudes to be equal. The electric field created by the ball has a formula, K Q over R squared. And the electric field by the plates, well, that number is given directly to us. So I don't need to replace that with any equation. So now I'm just rearranging for the R value. So it'll be the square root of KQ over the electric field. So numbers wise, K is the universal constant. I'll use 9 times 10 to the 9. Q is the charge of the ball, which is 10 coulombs, over E, the electric field created by the plates, which is 10 to the 10 coulombs. All right. So I take the square root of all that, and I believe the answer will be 3. I believe the answer will be 3. Because all those powers of 10, I think, end up canceling out. So it's just the square root of 9, which is 3. So r is 3 meters. And so to answer the actual question, the location of this 7th infinity ring is going to be 3 meters to the left of that ball. That ball is located at the coordinates 5, 5. So 3 meters to the left of that would have coordinates 2, 5.